Okay, next up we have Joel Swerdel presenting Evaluating the Effectiveness of Using Large Language Models for the Development of Concept Sets. Today's about LLMs.
So I guess LLMs and concept sets are a big deal this year. So this is my talk. These are my disclosures. So when you develop phenotype algorithms, one of the things that you have to do is get a list of concepts to be able to put together to be able to define the health conditions that you're looking for. In Odyssey, we generally use SNOMED codes, and they map to diagnosis source codes like ICD-10 codes that are used in the native data. We then get the selected concepts and we put them into a concept set. Our current method for doing that, for creating concept sets for phenotypes, is inefficient, subjective, and often inconsistent. The objective of this study was to evaluate the use of large language models for the selection of appropriate condition codes for concept sets used in phenotype algorithms. Our methods, we use the LLM to adjudicate whether a concept belongs in a concept set for a clinical idea. So let's say the clinical idea is acute myocardial infarction, and we want to know whether we should include coronary occlusion, the suggested concept, into this concept set. The way we would do that with the LLM is that we ask the LLM to whether there is greater than 95% of the patients with the suggested concept, coronary occlusion, have acute myocardial infarction. So we're using greater than 95% as sort of a cut point. Our process steps, first we define the clinical idea, let's say for instance acute myocardial infarction. Then we get a starting concept from SNOMED. So acute myocardial infarction, an appropriate concept ID for that is 312-327. Now the important thing is then we create a list of the starting concept, the descendants, and all the Phoebe recommendations from that. So these, if you remember in Atlas, there's a tab for recommendations. Phoebe gives a long list of recommendations for any included concept. So we create this whole list, and then we prompt the LLM with each of the concepts one at a time for it to do an analysis. We then parsed through the LLM selected concepts and created a new list of this greater than 95% concepts and its descendants. So then we create a second list of all the ones that were added in. We then prompt the LLM again for each of the new concepts for its analysis. We create a final list of all these greater than 95% concepts, and we post the concept set to Atlas. For our study, we tested the LLM process on 15 health conditions. We looked at acute health conditions such as acute myocardial infarction, chronic health conditions such as plaque psoriasis. For each condition, we created a human adjudicated concept set developed through a collaboration of at least 2 researchers with good experience in concept set development. And then these concept sets were then used as the reference standard to be used for comparison with the LLM adjudicated concept sets. For this study, we used the licensed Johnson & Johnson version of the OpenAI LLM, OpenAI model GPT-4o, trained through October 2023. And procedural calls to the application, to the API for the LLM were made through the R platform. We did a couple of evaluations. Our first evaluation was for concept evaluation. And we looked at 3 things. We looked at the concepts that were in common between the LLM and the humans. We looked at the number of concepts that the LLM generated that the human did not suggest, and the number of concepts that the human suggested the LLM did not suggest. We also looked at subject count evaluation, where we took a simple cohort using the concept set, and we compared the 2 concept sets from human and the LLM, and we used the Meredith CCAE database. And we did a similar approach to that, where we looked at the common subjects between the human and the LLM, the number of subjects in the LLM alone, and the number of subjects in the human alone. For our results, we found that the majority of concepts were shared by the human and the LLM adjudicated concept sets in 10 conditions out of the 15 total conditions. In the other 5 conditions, the LLM generally determined more concepts than the overall shared. We found some errors that I wanted to point out, just as an example. This is for the case of obesity. So false negatives, for LLM or human, the things that they had missed. So for LLM, the false negatives were obesity in mother complicating childbirth and childhood obesity. The humans missed obesity monitoring and has seen dietitian obesity. False positives, things that these two systems added in that are probably incorrect. The LLM added in increased body mass index and follow-up obesity assessment. And the human added in localized adiposity and fat pad syndrome. We then did a subject comparison. In 10 of the conditions, the LLM and human created similar concept sets. In 2 conditions, the human concept set had more subjects. An example here is angina, where the human included the code for chest pain, but the LLM argued, that probably 95% of the people with chest pain do not have angina. In 3 of the conditions, the LLM had more subjects than the human concept set. An example for this was nausea, where the LLM included vomiting, where it argued that greater than 95% of the subjects with vomiting also had nausea. In conclusion then, in our large language models to adjudicate whether concepts belong to concept set, we found many differences between those generated between LLM and those generated in humans. We found that one technique for this is found that it's valuable to use the LLM to adjudicate concept sets as a starting point for the humans to reduce some of the burden of looking through all the Phoebe recommended concepts. And once again, further evaluation is probably required to determine whether the UC-LLM constitutes a significant improvement in quality in the overall phenotype development and evaluation process. Thank you. If you have any questions, you can come to poster 604. But if you want some real excitement, come to the Phenotype Development Workshop tomorrow at 8 a.m. where we're going to have a human versus machine concept set development contest where we're going to have human adjudicators, well, we have to get human adjudicators, that are experts in the clinical field to adjudicate these things. Thank you.